Hello friends, Shoff here with you again in a long line of award-winning trig YouTube videos. And friends, the purpose of this YouTube video is to help you slay your own dragons about looking at a sinusoidal function and being able to write two sine equations and two cosine equations. Again, teammates, we could literally write an infinite number of sine and cosine equations, but let's just go with two. And the directions on your work for today said to write one sine equation where a, the amplitude is greater than 0, and one that is less than 0, and do the same thing for the cosine curve. So friends, let's give this example problem a go. So there's all kinds of places you could start. Certainly for me, I might think about trying to figure out what b has to equal. Now teammates, I remember that a period, the length of one full cycle of sine and cosine curves, is given by this expression 2 pi over the absolute value of b. Now friends, how about if we take a look at the graph and figure out the length of a cycle? Let's figure out what the period is. I often find that trying to figure out the distance from a hilltop to a hilltop is the easiest way to help figure out the length of a cycle. Teammates, if I started off here at an input angle value of -5 pi, hilltop, midline in here somewhere, valley, midline again, hilltop. This is the length of one full cycle. It looks like we're going to an input angle value of 3 pi radians. Teammates, that distance, right, that horizontal distance from -5 pi to 3 pi is 8 pi. So teammates, I can set 2 pi over b equal to 8 pi because I know this is the period, right? This is nothing more than direct substitution. And solving for b, teammates, I'm going to have b be represented by a positive number. When we have 2 pi divided by 8 pi, and when I simplify this fraction, teammates, it looks like I get the fraction 1/4. So friends, of my 4 variables, a, b, c, and d, I've got one of them. Hooray for us. Teammates, let's see if we can figure out what the amplitude is, and figuring out the amplitude will also help us figure out what the midline is. So it's like we're doing two things at once. We're multitasking a little bit. Teammates, if I look at the graph and look at the scale, it looks like I'm coming down here to a min value of -9. And it looks like my graph reaches a max value at +3. So teammates, don't I know then that the range is from -9 to +3? Teammates, doesn't that give me a distance, right, from min to max of 12? So that should mean that if I cut that distance in half, that would give me the midline, meaning -9 to 3 is 12, 12 divided by 2 is 6. I should be able to drop down 6 from a hilltop, a max point, or come up 6 from a valley, a min value, and that should give me the line of oscillation. Teammates, on the number line, what number is exactly between -9 and 3? I think it's -3. So teammates, doesn't that tell me that d has to be -3? When I sub in a negative in for d, the signs will change, right teammates? So won't I have y +3? Teammates, if I doubt my work, or if I just want to check my work, or maybe this is just going to help me in future operations, maybe I should just graph in what I think the midline is. Teammates, let's see if we can do that with a little precision. 1, 2, 3. Teammates, if I look at the graph, does that seem like it's the midline? Definitely. So friends, the only thing to do now is to decide where to pick up a left-right shift in order to write a sine and a cosine equation. And teammates, let's give the two sine equations a go. Again, teammates, just by looking at the graph, I might say, you know what? What if I try to write an equation for this piece, right? This section of this cyclical function. Teammates, let's give it a try. I know that y +3 is going to be common among the 4 equations, right? Meaning the midline is constant, it can't change. It's always the line y is equal to -3. Therefore, I'm always going to have y +3 on the left side of my equations. Teammates, if I'm writing for this section of the curve, This looks like a classic sine curve. I want the A value to be positive because I'm beginning at midline and I'm going to a hilltop at this first quarter cycle. So teammates, I know that I want it to be y plus 3 is equal to 6, right? Because again, aren't I going up 1, 2, 3, 4, 5, 6 to the hilltop, going down 6 to the valley? I want the amplitude to be 6. Teammates, I've got the sine. I've already solved for the B value, haven't we, teammates? And let me switch to marker. Hopefully you can see this a little bit better. 6 sine 1/4. Now, teammates, I'm going to incorporate a shift, right? Because what has happened here? The traditional sine curve starts here at 0, right? So this point has been shifted over. First of all, it's been shifted over right. So I want a subtraction symbol to signify that. And it looks like it's been shifted over pi radians to the right. So teammates, I've got my one sine equation. While we're here, let's just do another sine equation, teammates. Again, I'm gonna pick out a cycle, a piece of this sinusoidal function where I'm starting at midline and over the next quarter cycle, I'm going into the valley. And the reason for that is because I wanna use a -6 amplitude value. Teammates, again, y plus 3 has to stay the same. 1/4 has to stay the same because the length of a cycle is 8 pi. Now, teammates, let's incorporate this shift, meaning if I was starting here to be able to write this section, don't I need to shift left, add, how many pi radians? 1, 2, 3. 3 pi radians. And teammates, I've got my two sine equations. Let's give the cosine equations a go. Teammates, I know for both cosine equations, I'm going to have the y plus 3. I'm tasked to write one cosine equation with a positive amplitude and one with a negative one. I know the 1/4 is going to stay constant among all of my equations. Teammates, if I'm writing a cosine equation with a positive amplitude, that means I want to find a section of the curve that starts at a hilltop, right? Teammates, I identify this hilltop right here. Meaning I'm trying to write for this section of the curve, right? This specific section. So teammates, what normally is over here has been shifted so that that point, right, that hilltop is here. How far has it been shifted in what direction? Well, the direction is left, so I add, what's the magnitude of that shift? 5 pi radians. Teammates, how about if I look for a reflected cosine curve? Let's do this, teammates. Let's write for this section right here that would begin here and keep going and kind of look like this. Again, it doesn't really matter what the rest of that section looks like. I'm just interested in picking up where that reflected cosine section begins. Teammates, I know that I'm shifting to the right, so I want a subtraction symbol between my input angle variable and the magnitude of this shift. Teammates, here's 6 pi, here's 7 pi. And bam, as if by magic. Again, teammates, you could have possibly written other sine and cosine equations. I just happened to pick up these 4 equations just based on where I wanted to write an equation, meaning where do I want to begin a cycle? Schaff out.